It's very difficult to find real-life examples that also serves as good practice examples. Instead, we can use a code kata as a proxy for a legacy application to show some of the difficulties with working in that context. The Gilded Rose is created as an example of a legacy application with complex intertwined logic. Our task is to implement a new feature in this code. But first a bit of context on the Gilded Rose. You can find it on GitHub on this URL. It's implemented in a large number of languages. I'm going to use the C#.NET Core version for this tutorial. So what is the Gilded Rose? Imagine that we're in a fantasy type game and we're running an inn. It is selling different items, and the application implements the logic to govern how the qualities of the items goes down over time according to its type and its expiration date. Both the expiration date and the quality is updated every day. The application already implements logic to support a number of features, like once the sell date has passed, quality drops twice as fast. The aged brie item actually increases in quality the older it gets. Backstage passes, like aged brie, increases in quality as its expiration date approaches. If we run the program, it outputs a list of items and how they're changing the quality as the days pass. You can see an example of it here. Our task is to implement support for a new type of item called conjured items. They degrade in quality twice as fast as normal items. But as we look into the project, we discover that there are no tests implemented. And looking at the logic, we see a 73 lines long method that implements the core logic. It's not at all obvious how to implement this new feature. To make sure we don't break anything, we start by creating a test harness. The purpose of this is to make sure that we don't break any functionality without us noticing. So let's get started with the Gilded Rose. The first file we'll look into is the requirements file, which is part of the Git repository. It contains all the specifications of how the program works. If we scroll a bit down in the file, we can see that it contains in a bullet list the different requirements, many more than I mentioned earlier. We can also see the new requirement that we should implement the conjured item and how that's supposed to work. If we start by looking into the program, we can see that it contains a number of files. The two primary files that we'll be looking at is the program.cs file, which contains the main method, and then we're going to look at the Gilded Rose file, which contains the actual logic. The first thing that's defined in the main method is the items that is available for sale in our inn. It contains all the names, the sell-in date, and the quality. After that, we instantiate the Gilded Rose class, and after that we can use it to loop through 31 days, which is our month. At every day we will output the name, the quality, and the expiration date of each item, and then we'll update the quality based on the logic. If we open the Gilded Rose file, we'll see that it contains a single class called the Gilded Rose. It's instantiated by the list of items, and then we have one single method called update quality, which contains all the logic that's described in the requirements file. And as we can see as we scroll through it, there's loads of nesting. It's quite complex. There's no really any indication of which part of the code that is responsible for which of the requirements. And it's going to be potentially going to be quite difficult to implement our new feature in this method. So let's try to get the Gilded Rose tackled, get it under the test harness, and make sure we can implement this new feature we have been asked to do. So the first thing we'll do is to compare the requirement specification we have here with the actual code to serve as a guide for what we are supposed to test. Lucky for us, we have a requirement specification. That would not always be the case if we work with legacy software. So let's see what we got. We have a requirement saying that once the cell date has passed, quality degrades twice as fast. We already know that the quality is supposed to go down by 1 every day. So if it degrades twice as fast, then we would expect the quality to degrade by 2 every day after the cell date. So let's write a test for that. So we already have a test file which contains a quite useless test called foo. So we will use that. I usually use the convention test that as a signal to tell what I'm testing. So test that quality degrades twice as fast when expire date has passed. So if we tell it that it's the item foo, we know that the sell-in date is 0 and the quality is 0. If we set the quality to 10 and we update the quality, we would expect the quality to be 8. So if we run that test, we would expect to have a passing test, which we do. And that's a good thing. That's the first step. Now we'll copy this test to make sure that we also test the fact that quality degrades by 1 under normal circumstances. So if we set the sell-in date to 5, we would expect the quality to have been decreased to 9. So if we run that test, we have one more pass. We will look further into the specification and see that the quality of an item is never negative. I'll test for that as well. So we'll test that quality doesn't go to negative when it's 0. So if we set the quality to 0, we would expect the quality to keep being 0. And as we see, all 3 tests still passes. So let's continue with some more tests. We also have a requirement stating that hbre increases in quality the older it gets. So if we go back to our code, we can create yet another test. Test that hbre increase in quality as it ages. So we're going to copy the setup from the other test and have the hbre. Now we're going to have a quality of 10, sell date of 5. So when we update, we would expect the quality to go to 6. And let's try to run the test. Now we see that the test failed. There are actually multiple things going wrong here. First of all, the quality is 10, so it should not be 6, it should be 11. The other thing is that I called it an old brie, and that's actually not the name, because it's supposed to be called aged brie. So let's just fix that and see if that improves our test. Yep, so now we have one more test pass. We also have a requirement stating that a quality of an item is never more than 50. So let's try to write a test for that as well. again, we're going to copy the setup. So if we set the quality to 50, we would expect, because it's an aged brie, that it will increase, but our requirement states that it should be no more than 50. So let's see if that's true. Yep, and we have a successful test here as well. Now we'll continue to implement the rest of these tests to make sure that we have everything covered. But just to make sure that that we know where we are, we can use a cover to get a code coverage of the test we have implemented until now, to see if we actually cover all the code inside the gilded rows. So the way it works is that we have this bar in the left side. All the lines which have a green marker is hit by a unit test, and if there's some of them which are gray, they're not hit. So let's see if we have any gray lines left. It seems we have something here. So now we need to craft a test that will actually exercise this piece of code. This is actually a more real-life example than having the specification, because in many cases we don't have a specification, so we would need to read the code and try to understand what it does. So in essence, it's actually a quite more realistic example. So to have a test that hits that piece of code, we can see that the sell-in date must be less than 0. We can also see that it should probably be a backstage pass, and then this piece of code will be exercised. I'm not quite sure what it will actually do, so I'll start by just creating a test and call it foo. And then I'll rename it after I'm kind of resonate around what the code actually does. So if we copy our setup again, see it's a backstage pass, our sell-in date is set it to -1. Our quality is 10. And then we don't know what to expect, so I'll just write 100, because definitely the quality will not go to 100 when we exercise this code. So the test fails, and let's just see if we run this test with the coverage, then we should be able to see if we actually hit the expected part of the code. So if we go here, I can see that our test failed, and it covers this part. What this code actually does, in a very convoluted manner, is that it takes the quality of the item minus the quality of the item, which will always return 0. So that actually matches with the requirement that quality drop to 0 after the concert. If we can do a coverage pass again. This is something that usually happens when you craft tests for these specific examples, because you need to continue creating tests until you believe that you have sufficient coverage to feel confident that changes will not, well, explode or create other issues when they're introduced. We still have this part of the code. So this else statement should be matched by, let's see. So if the sell-in date is negative and it's not an aged brie and the quality is less than 50, if it is aged brie, the quality should increase by 1. Let's see if we already had a test for something like that. So if we look at this one, oh, that's for a positive sell-in date. So let's just copy this test. So if we set this to 0, we would expect it to increase twice as fast. Let's see if that does what is expected. And let's just run the coverage again to make sure that we have all our paths covered. So now it seems like we have green everywhere. This is a method that contains many different paths. So to actually create unit tests that covers every combination of path through all of this method is, I would say, a very daunting task. So we're not going to do that. You just have to continue adding tests until you find that you're confident enough to introduce this new feature. Now we're kind of ready to start implementing our new feature. So the requirement says that we have recently signed a supplier of conjugate items. This requires an update to our system. Conjugate items degrade in quality twice as fast as normal items. So with that specification in mind, we would need to start with implementing a test for that. So we're going to put in one more test. Test that. Conjugate items degrade in quality twice as fast. And again, we're going to copy our setup so we don't have to type so much. Conjugate. We have a sell date in 10 days, quality of 10. And we expect the quality to drop to 8. So let's try to run this test. Of course, we haven't implemented anything for conjugate items, so we would expect it to fail, as it does here. So it's actually 9, which is the expected for a normal item, but we would like it to be 8 because we have this new requirement. So now we are ready to try to implement this into all of this code. So first of all, we need to find an insertion point to actually put in this new feature. So let's see, a conjugate item is definitely not an HBRE and it's not a backstage pass. We expect the quality to be more than 0. And it's not so first hand of Ragnar. So we'll put it here. So items name contains conjugate. If it does that, we want to decrease the quality by 1. No, want to decrease it by 2, of course. So let's try to run our test again. So now we have a success. So usually what happens here is that now that we have a test harness covering all of the code, we can use that as a safety net to actually refactor this, because when we look down on this code, it doesn't really feel like a very nice, well, it's not easy to put in stuff and be 100% sure that it actually works. So I'm not right now 100% sure that this will actually always work, but we can use it to actually refactor, but we'll look at that in at some other time.